Okay, guys, here we go. Took me a long time to work up my courage to try to videotape this, but I'm gonna give it a shot. This is number 11. You read it on your own. Here we go. Okay, you want the maximum area of a rectangle inscribed underneath this cosine curve. Okay, I redrew it over here. Main idea is if this is the cosine curve, then this point right here is over x and up y, but instead of calling it xy, call it x and cosine x, which is what y equals. Then we need to write a formula for what we're trying to maximize, and we want the maximum area. So if you want max area, you need to write a formula for the area of that rectangle. And the area is, this was over x and over x the other way, so it's 2x times cosine x. Now to find the maximum of that, you could find the derivative and set it equal to 0, but this is a calculator question, so you can just plug this into your calculator and look for the maximum, or you could find the derivative and set it equal to 0 and do it that way. Either way, you're going to have to graph it. So rather than risk finding the derivative, I'm going to actually graph this and look for the maximum. But if I do it that way, I have to make sure I use a decent domain or a good window. So if you look back at this cosine graph, x, which was one direction, one way this way and one way this way, x has to be less than pi over 2 because this is the cosine graph and it has to be inside that. And cosine is 0 at pi over 2. So my x's for my window are going to go from 0 to pi over 2. It can't be bigger than that. So now I'm going to take my calculator and graph this equation, 2x cosine x. And keep in mind, we're not looking at the derivative. We're looking at the actual graph of area, and we're looking for the maximum area. So I graph this with the restricted window. I went from 0 to pi over 2. I'm still going to count by ones because that's what they did on their graph. The y's, I'm guessing, it could be -5 to 5. If I don't see it, I'll change it. So let's see what that graph looks like and see if I can see a maximum. And I can. So now I just need to make the calculator give me this point right here. So second calc, maximum, get to the left, get to the right, and there you go. But I just did this question a little while ago, and I would have gotten it wrong. X is 0.860, and I thought that was the answer, and I went and bubbled A. Yay, I got it. Nope. Make sure you reread the question. The question says, what is the maximum area? They don't want to know what are the dimensions. X would give me half of the dimension of the rectangle. That's not what I want. I want the actual area. So keep in mind, when you're looking at this equation right here, the x's represent part of a length of the rectangle. The y's represent area. So the answer could be the x or the y. In this case, I want the maximum area, so the answer is 1.122, which is C.